My name is Alberto Marquez, and we will discuss in this video the Arena basic processes. This is the beginning page for starting any model. Notice that we are in basic process, and in basic process we have a create module. I will bring it to the working space by clicking and dragging, and I will do so with process and with dispose. This would be the easiest possible model you can build, and the create module will allow you to define the time between arrivals. In this particular case, it is a pre-default as random with exponential distribution, and the units is hours, but you can select anything else that you want. I will leave it as hours. Time between arrivals equals 1. Of course, this would have to be adequated for the particular model that represents the reality of your system. And we define that there is one entity per arrival, and we don't define the maximum number of arrivals. If we select process is defaulted to not require any resources. And it's just a delay. It's like if you're trying to dry fruit and you just put it outside to the sun, all you have to do is wait a certain amount of time, and eventually it will be dry. But sometimes some of our process needs a worker, a machine, a tool, or other means of transformation. And for that, you need to seize the resource while you execute the transformation. Let's get a seize, delay, release, which actually seizes the resource, then delays for a while still holding the resource from other entities, and then after it's done with this process, the resource is released. We can define the resource that we want, and we can add one to the list. The default is resource 1, but there is no problem us defining other resources directly here on the screen by typing the name. Let's say we need a worker and only we need one. Sometimes the entities may need more than one resource in order to be transformed in a particular situation. In this particular case, let's assume we only need one, and that worker is going to be seized and it's going to be held during the transformation process, and after the transformation is finished, it will be released. So the worker will be able to take care of the next entity. We make the assumption that the triangular distribution is the best that one describe this particular transformation. I will make it work a little faster by reducing the service time from 1, say, to 0.8. And now, because it's a triangular distribution, the minimum is 0.5, the minimum time, the most likely is 0.8, and the maximum time is 1.5. We have the option to report the statistics associated with this resource and this process, and we did so. So we select that, OK. And finally, the last module is just a dispose. Notice that after we selected the resource in the process module, we obtained this line that looks like a T. Actually, what this does is this represents the queue where entities will be set up in line as a buffer before entering into the process, before the resource, in this case the worker, can actually transform them. So if we execute this model right now, it is compiling, and after compilation you can see it executing. You notice that the animation represents where the entities are either in the process of going into the queue or from the process after they're done going into the dispose. We can pause this simulation, and if we would zoom in, you can see that in this little time 1,446 entities have been through the system simulated with Arena. Very good. Let's make this video to the point and short, and I will make another one. Very good. Now what we can do is we can embellish this model, making it more comprehensive. So what we're going to do now is we're going to change the type of process that we have. I'm going to have to stop the simulation, because now what is going to happen is the worker will take this entity and we'll prepare it before taking it to the machine. In the machine it will be processed, and then immediately both the machine and the worker will be released. In order to do that, I need to include two processes, and I will explain those two. First, if I bring those two processes, you will notice that this time they are interconnected between each one of them, because I brought them sequentially one after the other. But I need to make a connection. To make the connection, I have the connector here in the top of in the menu, top of the menu. Go to the triangle, click, and then go to the next end for the process I need to connect. And I will need to do that one more time, from process 3 to the end of process 3 to the beginning of the dispose. Very good. Now that we have this, what we want for the process 1 is not cease, delay, release, but only cease and delay. And the delay is just going to be 0. Well, not 0. Let's say that there is this process that we need to execute, and hit OK. And then they have to go to a machine. The machine will do the cease, delay, release pattern that we've seen, and this is going to happen in a resource named machine, for which we have one machine. Well, let's leave everything else the same. Well, let's change these to something else. Maybe it's a constant process, always takes the same amount of time, and let's say it always takes 0.9 of hour. That's 0.9 of hour. That's 54 minutes. And finally we go to process 3. In the process 3, the only thing we are going to do is just delay and release. What are we going to release? We're going to release the worker, that one worker that we needed and that we took in process 1. So in order for that resource to be available again for the next entity, we need to release it, and that's what we did in this case with process 3. We delayed it in process 3. One more thing that I need to do is to define the number of resources, and let's say that I have 3 workers, but I have only one machine, right? So I can prepare the entities and carry them to the machine, but there's only one machine, and the bottleneck will probably be in the machine. So having done this, I can run my model. Of course, from this moment on, we will collect statistics and see what is the utilization in each one of for the worker, what is the utilization for the machine, the total time in system, etc. Okay, we will continue with more in the next video.